All right, guys, let's go over this worksheet. This will be the last one that we go over that's just participation. After this, they're going to be for a grade, and we also need to know how to do this so that we can still do section 3 and section 4 of chapter 8. All right, so this one is just mole to mass conversion, and if you remember that guide that I wrote for you guys where I was like, okay, grams of 1 to moles of 1 to moles of my new substance, if they're asking for a new substance, and then 2 grams of my new substance. So this one's going just from moles to grams of 1. It's just going from here to here. So it's a one-step problem to do. We're going to have to use the periodic table to get these answers. But other than that, it's just a simple one-step problem. Now you are going to have to know like ammonium chloride, and I'll walk you guys through that. So ammonium is NH4, and it is a +1. Chlorine is a -1, so it's just NH4Cl is what this is. So NH4Cl is ammonium chloride. So if I have 0.436 moles of NH4Cl, and I want to know how much that weighs, how many grams, I'm going to put moles on bottom, and I'm going to put grams of this on top. Now, it's just taking nitrogen, knowing that nitrogen weighs 14, hydrogen weighs 1, but there are 4 of them, and chlorine is 35.5. You're going to add all of those together to get, let's see here, make sure I'm on the right page here. It is 53.5 grams. So you're going to take 0.436, multiply that by 53.5, and you should get 23.326. All right, so if you need to stop or write down, what you should be doing right now is writing down in a different color, like a colored pencil, a pen, something different than what you did this in, so that we can see maybe what went wrong if you got it wrong, and you can correct what you did do wrong so that hopefully in the future it doesn't happen. Right? All right, on the second one here, I have lead 2 oxide. Now what that Roman numeral means is that that is a +2. Oxygen's a -2, so it's just PbO is lead 2 oxide. So if I start with 0.360 moles of lead oxide, now I want to know how much that weighs. Well, I know 1 mole of lead oxide weighs, well, I'm going to have to see lead itself. Lead weighs 207 if you round, and oxygen is 16, so that's 223 grams of lead oxide. So I'm going to take 0.360 and multiply that by 223, and I am going to get 526.28 grams of lead oxide. All right. So let's do the third one here. I have aluminum iodide. So I'm going to kind of walk you guys through this. We have aluminum, and I have iodine. So if you guys can figure out what the charges are of aluminum and iodine, we can then see, okay, well, what's the formula for aluminum iodide? Because if I don't have that correct, then my grams are going to be wrong, which will make my whole problem wrong. So aluminum, if you're looking on your periodic table, is a +3 charge. Iodine is a -1. So we have to do that crisscross method. So what that gives us is AlI3. So I'm starting off with 0.031 moles of AlI3 and 1 mole of AlI3. I need to know how much that weighs. So if you look on your periodic table for aluminum, it is going to weigh 27. Iodine weighs 127, but there are 3 of them, so I've got to multiply that by 3. So I'm going to take 27 plus that 127 times 3, That all together is 408 grams. So 0.031 times 408 is 12.648 grams. All right, so let's look at the next one. We have magnesium phosphate. So magnesium is Mg. See if you can find your charge for that. Look at your periodic table. And the charge is a +2. Now phosphate is on that special sheet, that polyatomic ion worksheet. If you need that or you need a copy of it, let me know. I will make sure to get you one. But phosphate, if you look at that sheet, is a -3. So when you crisscross these to get their charges to cancel, you get Mg3, and then you got to put PO4 in parentheses, and there's 2 of them. So now I'm going to start with 0.077 moles. And I know that in 1 mole of this, I'm going to try to get grams. So magnesium, if you look on your periodic table, you will find that magnesium rounded weighs 24. There are 3 of them. Now there are a couple of ways you can do the PO4. What I did is I looked and saw how much does PO4 add up, and then I multiplied that by 2. You could do, hey, there's 2 phosphorus, so it would be 31 times 2. And you could also say there's 8 oxygen, so 16 times 8. You're going to add all of those numbers together, and you should get 262 grams. All right, now when you take 0.077, multiply by 262, you get 282.174 grams. All right, now the last one in this section is calcium nitrate. So calcium is Ca. Go ahead and find the charge of that. You look on the periodic table, it is a +2. Nitrate is NO3. It's on that special polyatomic ion worksheet. It is a -1. So what this is Ca, and NO3 is in parentheses, and there are 2 of them. Now it tells me that I have 0.5 moles of CaNO3 of calcium nitrate. So in 1 mole of this, I need to figure out how much all of this weighs. So if you look at your periodic table, you will find that calcium weighs 40. Nitrogen is 14, but there are 2 of them, so that's going to be 28. And then oxygen is 16, but there are 6 of them. So you're going to add 40 plus 28, and then whatever 16 times 6 is, all of that together should give you 164 grams. You're going to multiply that by 0.5, and this answer is 82 grams. All right, so that's your simple 1 steps. Now the next ones are also 1 steps because you're doing the opposite. Here we were going from moles to grams, and now I'm going to go from grams to moles. So I'm just going back and forth. All right, sodium chloride is Na, it's a +1. Chlorine is a -1, so it's just NaCl. So if I have 23.5 grams of NaCl, I'm going to look at this in sodium. If you look at your periodic table, it's going to be 23 grams, and chlorine is 35.5. So when you add all of that together, you get 58.5 grams. So you can see now where my grams are on bottom instead of like it was before. Now my moles are on top. So I'm going to take 23.5 divided by 58.5, and that is 0.4 moles. All right. Let's look at sodium cyanide. So sodium is Na, it's a +1. Cyanide is Cn, and it is a -1. So you just get NaCN. All right, 0.778 grams. Now when you add NaCN together, you should get 49 grams in 1 mole. So you're going to take 0.778 grams divided by 49, and that is 0.016 moles of sodium cyanide. All right. I'm going to go a little bit quicker here, so if you have any questions, kind of make note of it and ask me. Water is H2O, so I'm going to take 0.250 grams of water. Water weighs 18 grams for every 1 mole. Hydrogen's 1, oxygen 16. There are 2 hydrogens though. So 0.250 divided by 18 is 4.5 moles of water, of H2O. All right, number 9, you need that polyatomic ion sheet again. So we have calcium, which is a +2 charge. Acetate is on that special sheet. It is a -1 charge. So what happens is you're going to crisscross these things, and that becomes a 2. So I'm going to take 169.45 grams. I'm going to take all of this. I've got calcium, which is 40. I've got carbon, but there are 4 carbons, and they each weigh 12. I have 6 hydrogens that each weigh 1, and I have 4 oxygens that each weigh 16. When you add all that up together, it is 158 grams. If you have been struggling with getting the right weights, masses down, practice that. Make sure you're doing the same thing I am. When you divide those two numbers, it is 1.07 moles of calcium acetate. All right, and then lastly, I have potassium permanganate. So potassium is a K with a plus sign. Permanganate, if you look on that special sheet, is MnO4, and it is a -1, so everything's good here. There's no crisscrossing, the charges cancel. So I'm going to take 79.9 grams, and for 1 mole, I need to figure out how much that weighs. If you're looking, potassium weighs 39, manganese weighs about 55, and oxygen weighs 16, but there are 4 of them. So add all that together, it is 158 grams. And that is going to be 0.51 moles of potassium permanganate. All right. Now we're going from moles to particles. I'll give you the answers on this, but this is not something we need to do in Chapter 8. All right, so I'm just going to write down the answers because this, once again, I'll kind of show you here. If you were to set this up, moles is here, so I'm going to put moles on bottom. Particles on top. 1 mole of anything is 6.022 times 10 to the 23rd. Now that 6.022 times 10 to the 23rd has a mass, and that's what we were just doing, but that's how many particles there are. Right? So if you multiply that, it's 2.7 times 10 to the 22nd. Number 12, I'll go ahead and give you the answer. You can set this up if you want, but the answer should be 7.2 times 10 to the 23rd. And 13 is 1.9 times 10 to the 23rd. Okay, so that is the first page. I will then put up a video and post it with the second page so that these videos don't get too long. You can kind of do them one at a time. All right, let me know if you need anything. Thanks. Bye.